Hello everyone, welcome to the Introduction to Mechanical and Industrial Engineering course MEC 130. This is a new video. In this video we are going to discuss the manufacturing. This subject is of interest to both mechanical engineers and industrial engineer. So manufacturing is one of the manufacturing processes or making the design. This is one of the steps or the steps of the general procedure of the engineering design. We said that once we do the detailed design and we represent our design over some graphics and some engineering drawing, then we have to move to make this design. We have to bring it into reality, and this can be done through a manufacturing process. So that's why over this video we are going to discuss these manufacturing methods. And we are going to explain to you what does it mean manufacturing. Then we are going to discuss the classification of the manufacturing processes as a general classification. Then we are going to go over or mention the most commonly used manufacturing methods as engineer. And again, this subject is of interest to both mechanical and industrial engineering. All right, so what is manufacturing? Manufacturing simply can be defined as making a product, or we can define manufacturing as convert a raw material into a useful product, or we can define manufacturing as to enhance or add value to previously made products. So there are lots of keywords here that have been mentioned, like raw material, products, so we are going to explain them, but something that you should understand in general, product manufacturing is to produce something from scratch, or to add value or enhance or do any changes to any material, whatever it is. So these changes and the process to do these changes, this will be counted as manufacturing. So first, to give you more detail, let us define what is a product. We said that manufacturing is to make a product. So what is a product? Product in general, it is something that is useful, that is something that we can use. But in terms of manufacturing, product, this is the output of the manufacturing process. So we can draw like a typical flow chart of the manufacturing method. Like we should have input, so this is the manufacturing method. Process. And we should have input to this manufacturing method. This input, it will be known as the raw material. And after the manufacturing, this is the output of the manufacturing process, we can give it the name as product. So we can count the product as the output of any manufacturing process. But the input to this manufacturing, it could be considered as a raw material for this specific manufacturing method. Like in order to do a manufacturing, you should have first a raw material, you should have a material. This material is gonna go through a certain process, go through a certain manufacturing process to be converted into a product that we can use. So product in general, it is something that we can use, which also we can define a product as the output of a manufacturing process. But the raw material, this is the unmanufactured method, or this is the material before manufacturing. This is the input for any manufacturing process that it shall be converted into a product, which it will be the output of the manufacturing method. So simply we can define manufacturing is to make a product or produce a product, or to convert a raw material into a useful product, or even to enhance or add value to previously made products. For example, one of these typical examples of enhancing value of products is the steel making. We said that steel making, it is a huge industry. Alloying, it is a huge industry. Steel, we said that as we discussed over the previous videos, iron, it is a weak material. It is not useful in terms of engineering, so many engineering applications. And in order to add value to this iron, we have to add a small fraction of carbon. This carbon, it is non-metal. This process is known as alloying, as we explained before. Adding the carbon is going to do changes to this material, is going to change the material from being iron to be steel. These changes require a process that we have to follow. This process is known as steel making, and it is a huge industry. It is a manufacturing method. It is a process or a manufacturing process. So we have to go through procedure to do this steel, to convert the iron to steel, And by converting iron to steel, we are adding value. We are enhancing the properties of the iron by making it steel, by adding a small fraction of the carbon. The addition and the process needed to add this carbon and convert the iron into steel, this requires a manufacturing method or different set of manufacturing methods, so it will be counted as a process. We have to go through procedure to convert the iron into steel. So generally speaking, manufacturing is in general, we can say that any changes that we do to any material, to any product, it will be counted as a manufacturing method or a process, and we should go through process. A typical example to this, for example, if we're gonna choose this pen. This pen now it is a product, it is final product. Before we receive this pen, it has been gone through multiple manufacturing methods or multiple manufacturing procedure or processes till we gonna end up with this pen as a product that we can write with, that we can use. But how about for some reason, if you are not interested in the shape of this pen and you decided to glue some things over this surface of the pen, you're gonna glue lots of things here with the aim of giving more better shape and like adding decoration to this pen. So the decoration, adding this decoration, it will be counted as a manufacturing. Why? Because you have done changes over this conventional pen. So this is the pen before the decoration, it will be counted as the raw material. After gluing things to it and after adding the decoration, it will be counted as a new product, another product. And the process of adding the decoration, this requires that you go through certain pattern and process. This counted as a manufacturing process. So generally speaking, manufacturing is to do changes to anything that we can use. Before and after the changes, this requires a manufacturing method. So this also indicates that manufacturing, it is not necessary to be something that is strictly related to the engineering, despite basically we define manufacturing as something that is related to engineering, whatever mechanical or industrial engineering. But in general, manufacturing, it is not necessary that it requires special tools or requires special machines. We can do even manufacturing by hand. As I mentioned, if you glue things here by hand, so this is hand making. It is also manufacturing method. So it means that manufacturing doesn't necessarily require using special machines or tools. As I said, we can do manufacturing by the bare hands. So generally speaking, again, manufacturing is to do changes over any material. This is something that can be added to this list as a definition of the manufacturing. All right, so what about how many manufacturing methods or processes that we could have based on these definitions of the manufacturing? As we mentioned, manufacturing, any changes that you do to any product, it will be counted as a manufacturing method or process. So this indicates that the count of the manufacturing processes, it is countless because we can do lots of changes. As I mentioned, any changes over the product or over any material, it will be counted as a manufacturing process. So it is countless. We cannot count how many exactly manufacturing method that we can do. But there are some general names and there are some general classifications of the manufacturing methods. Generally, we can provide a general classification into the manufacturing methods into three groups. Into shaping processes, there are some of manufacturing methods, and they are a lot that they can be counted as shaping processes or shaping manufacturing processes. There is another group of manufacturing methods that will be counted as forming manufacturing methods. There are some other group of processes that will be counted as machining processes or machining manufacturing methods or machining. So we do have three groups. We can simply group all the manufacturing processes, which a lot, into three groups: shaping, forming, or machining. So what is the difference? All right, so in shaping, the product is produced by melting and pouring a raw material into a prepared mold. Or in general, we're gonna say that shaping, it requires melting the raw material to be shaped into another form. Typical example of these shaping processes are casting and welding, and there are some other. Anything that is very similar, it will be counted as shaping. So generally, what does it mean shaping? As a typical example of the shaping process, that we are going to melt. Melt, it means that you have a metal, and this metal will be, usually it comes in the solid state, it is solid, and by putting into the furnace and melting the melt, it means that you are going to convert the solid state of the melt into a liquid state. This requires that you put it into a furnace at a very high temperature. In many of the cases, it could be higher than 1000 degrees Celsius. Till it will be completely converted into melt, into liquid. So melting, this is just to convert the metal from the solid state into a liquid state, make it liquid. So if we are going to convert the raw material, which in many of the cases is gonna be metal, as we are talking about engineering in terms of manufacturing process that used for engineering, that we have to bring the metal in the solid state, then we're gonna put it into the furnace, melt it. It means that you're gonna convert it into liquid, make it liquid, then you're gonna pour it. Pour it, it means that you're gonna put it into a cavity or into a shape. Then it's gonna take this shape. This will be counted as a shaping process, and this is typically what we are doing in casting. Another process also, that manufacturing method that could be considered as shaping, is welding. And I'm pretty sure that you do have an idea about the welding, and you have seen this method before. Welding, it means that, for example, you bring a raw material, and then you're gonna join this raw material to form a shape. So that's why we got the shaping process. Welding, it means, as I mentioned, that you bring different materials, different parts together, and you're gonna weld them at the contact surface between them. When we weld, we have to melt. We have to melt the raw material, these two parts, at the welding zone. Welding zone, this is the area at which we already welding, as shown here in this figure. Like at this sparks that already seen, there are very huge amount of heat is generated that is going to melt, is big enough to melt these two pieces that we would like to hold or join together by welding. So that's why during the welding process we have to melt the raw material. It is not melting to the entire material during the welding process, but at least within the weld zone, within this little small piece, which is known as the weld zone, the material is completely melted, is completely converted from the solid to the liquid state. This is known as melting. Melting, if you have a metal in the solid state and then you are going to make it liquid, this requires heating the material at a very high temperature. This is known as melting process. So generally speaking, any manufacturing method that involves melting the raw material, this will be counted as shaping. Like as I said, that you're gonna melt the raw material, pour it into a certain cavity, into a certain shape, to end up with to a prepared mold. Mold, it means that this is a cavity or a shape that will be this is gonna be imparted after that over this melt. A typical example to understand this process is making ice. If you're already handling a cup and you pour some liquid, this liquid, it will be water, for example. If you pour liquid, which is water, which is already liquid, into a cup, the liquid is gonna take the feature of the interior of this cup. Then you're gonna put it in the fridge and leave it for a while till it will be solidified, till it will be converted into ice. Now it became ice. Once you break, or you can simply get the ice out of the cup, in that case you're gonna end up with a shape. So we have converted the liquid into another shape. This process is known as casting. This is the physical meaning, or what does it mean, a casting process. Don't stick to the word itself, what does it mean, but once I mention casting, the thing that should come in hand is the process. What does it mean, casting? Casting is to melt a raw material, melt some metal, pour this metal into a mold. This mold is gonna work like the cup. And the metal, the melt of the metal, this is the water that you are pouring inside the cup. So the cup, it's gonna be the mold. What does it mean, mold? This is gonna work like the cup. And what is the melt? This is the metal that has been converted into liquid. Then you're gonna pour this liquid into the cup, into the mold. Definitely the liquid is gonna take the feature of the interior of the mold or the interior of the cup. Then you're gonna leave it for a while till it will be converted into ice or converted into product. This is casting process. What does it mean? Make sense? So casting is one of the manufacturing methods that will be grouped as shaping. Also welding, it is a manufacturing process that can be grouped as shaping. Why welding is counted as shaping? Because we are shaping products, or we bring in shape, making shapes by joining parts together, and this requires that we have to melt the metal at the welding zone. So as long as there is a melting process involved, this will be counted as a shaping process. And this what makes shaping is different than forming. Forming is another group of manufacturing methods or another approach of manufacturing. Forming a product is produced by exposing the solid raw material. So the raw material, it should be solid. It shouldn't be liquid. There is no melting anymore. There is no conversion into liquid. Instead, the material, we're going to keep it as solid as it is. But we probably would heat the material, but still the material should be kept in the solid state. We are not converting the material or the metal into liquid. There is no melting in the forming process. But if there is melting, is going to happen to the raw material, this indicates that you are doing shaping, not forming. So forming, it involves exposing the material into a very high force in order to change the shape of the material. We said that if you are going to do change over the shape, this will be counted as a manufacturing method. So forming is any manufacturing method that would require changing the shape of the material while it is in the solid state. A very simple example to this. For example, if I give you a stick that is made of steel or iron or aluminum, any metal, a piece of a stick, which is already 100% straight. Then if I handle this stick to you and ask you to bend it, so this stick, it will be bended in this way. So it's gonna take another form, another shape, right? This is a manufacturing method. This manufacturing method is counted as forming. So I have changed the shape of this stick from being straight to be bended. It's gonna take the angle shape. This is metal forming. This is forming process. I didn't melt the raw material. It is still in the solid state, and you had to expose some force, expose this material, or apply some forces over the stick to be bended. And this force, it should be big enough to bring the material to the plastic deformation. If you compare this example to the same example that we explained when we were discussing the difference between elasticity and plasticity. So we have brought this material into the plastic zone. We are plastically deformed this material to attain a new shape. This shape is different than the before manufacturing. So this could be counted for this manufacturing process as the raw material, and this is gonna be the product after this manufacturing method. What is the thing that you have done? You just simply apply certain force over this solid material that have been converting with the aim of converting its shape from one form to another form. This will be counted as a forming process. The volume is usually constant before and after forming. There is no changes over the volume of the product. It is still the same. You have a stick and you just bend it. Nothing has been happened to the volume. The volume is still the same. Before manufacturing and after manufacturing, it is still the same. This indicates that the volume is preserved up on manufacturing by forming. Examples, the material can be heated in some cases, but no melting. There is no melting for the material. But if the material is going to melt, and then we are going to pour the material into a mold, this will be counted as a shaping process, like casting or welding. But in the metal forming processes, which is a group of lots of manufacturing methods, that we are exposing the material into a force without, we could heat it, but there is no melting. And in the meanwhile, the volume is preserved. It means that the volume before and after manufacturing, it is the same. Examples of these are a lot. Examples are rolling, forging, extrusion, drawing. This figure shows the typical example of a forging process. Forging process, as you can see, just observe the guard. So this guy, so you can imagine how huge is this machine. And this is a hammer. This hammer is moving very fast and hitting over this piece of metal. This piece of metal, which is very huge, it is clamped and it is held by this handle to give it kind of rotation. Keep on twisting and rotating this piece, and the hammer is keep on moving up and down, hammering over this to change the shape. So this hammering action, this is a very high force, as the impact force, as we explained before over the last videos. This impact force is big enough to change the shape of this raw material to another shape. This is counted as a forming process. As you can see, the sample or the material here, the material, it has a reddish color. This red color because it is heated. This is, we have bring this metal and we threw this metal into a furnace at a very high temperature, and we kept this metal inside the furnace till it will be heated to a certain temperature. Then we brought it into this machine and we are doing forging process. So as you can see, it is still in the solid state. It is heated, yes, but there is no melting. It is not liquid, it is still solid. And we are doing this forging process. This will be counted as forming process. This is a second group. The third group is machining. What makes machining is different than forming or shaping is that the product is produced by cutting a chip, that we have to cut something from the product. This will be counted as a machining. Cutting a chip from the product of the raw material, to end up with a product, this will be counted as a machining process. There is a material waste in the form, it means that the volume is going to reduce in the form of a chip that is going to form. Like for example, if you do have a piece of wood, think of it like you do have a piece of wood, and you simply have been used a very sharp tool, whatever this tool is, like assume that you already handling this tool, and for some reason you're gonna push against the wood. So as you push, there is something that is going to come out, that is going to be cut from the surface of the wood. These things and this like extra part will be removed. It will be counted like the waste, right? And as you keep on hitting too, because it has a very sharp edge, as you keep on hitting over the piece of wood, there are some certain chips. These things that comes out of the surface, this will be counted as the chip. This chip, it is a waste. It represents a reduction in the volume. The volume will not be preserved like the case of metal forming. In forming, the volume before and after it is the same. But here we do have a reduction in the volume in the form of a chip. That this chip, it should be reduced, and this chip will be counted as waste. Any process that involve forming or cutting a chip from the raw material to end up with another product, this will be counted as a machining process. Make sense? Examples of these are turning, drilling, shaping, milling, and grinding. Don't mix between the shaping process as one of the processes that is used for machining and the shaping as the category, a general category of lots of other manufacturing processes. Shaping here involve casting, welding, and other things. Any process that involve melting the raw material, this will be counted as shaping. Any process that involve exposing the material into high force without melting the material and keeping the material in the solid state, and the volume is preserved with no melting, is counted as forming process. Any process that is involved forming or cutting a chip from the material in order to end up with a product, this will be counted as a machining process. Shaping is one of the machining, not this shaping. Don't mix between this shaping process and this shaping as a category. Make sense? So these are the three categories or the three types or the general classification of the manufacturing methods in general. Now let us consider some of the common types of manufacturing method that could be counted as shaping or could be counted as forming or could be counted as machining. We said that these are the three categories. So we're going to go over some of the most common manufacturing processes or methods that could be within every one of these groups. Like for example, in the shaping, we are going to discuss the casting process, and we are going to discuss the welding process. Also in the metal forming, we are going to discuss rolling, forging, extrusion, drawing, sheet metal working. Also in machining, we are going to discuss the turning process, drilling, shaping, milling, and the grinding process. Make sense? So this is what we are going to discuss. And something that you should understand here, don't stick to the word. Don't stick to the name of the process. But the thing that you should understand, once we mention the name, the process itself should come in mind. Like for example, when we say casting, this procedure is the thing that should come in mind directly. I don't care what does it mean, the word casting itself, because casting, it could be used for lots of application. But in terms of manufacturing, when we say that casting as a manufacturing method, the procedure is the thing that should come in mind directly. Don't stick to the word, but stick to the procedure. So let us start here with the shaping process. We said that any process that would be counted as shaping process, it should require melting the raw material. A typical example and a very common example of the shaping process is casting. And casting, it is not just one method. Casting, it is a huge industry. Casting, it involves so many manufacturing methods that would be counted as casting. So the casting, there are lots of methods of metal casting. This is generally speaking known as metal casting. And as I mentioned, it is not just one casting process or metal casting process. There are lots of metal casting processes. One of them is sand casting. But in addition to the sand casting, we do have metal die casting, we do have centrifugal casting, we do have so many other casting processes. The most common one and the simplest one is the sand casting process, which is a good example of the casting method. So casting, it is not just one method. It is lots of methods that will be counted as casting. One of them is the sand casting process. So in the sand casting process, for example, or casting in general, it is the process of melting and boring. So there are two things that we have to do. First, we have to melt the metal. We have to melt the raw material, as I mentioned. Melt, it means to convert it from solid to liquid state. And the second step is just to bore it. To bore this metal into a pre-prepared mold. We said that this mold should involve a cavity. This is like the cup that has a cavity, and then you're gonna pour the liquid inside it and leave it into the fridge till it will be converted into ice. The same thing here. In the casting process, we have to melt the raw material, pour it into a cavity to end up with a product. A typical example of this casting process is the sand casting. So to explain to you the process, how it is done, and give you more detail, I'm going to let you with this video. Alright, so this is a very good example of the metal casting process. In this video, this guy is trying to make something of metal casting.
Exactly what's involved from start to finish, the desoldering. So
yeah, this is the final product, you could say, that he is interested in making. And through this video, he didn't just use casting, but in addition to casting, he used like welding and lots of other manufacturing methods in order to bring this product into reality. So this is the final product. And as I said, this requires a procedure to make it. This procedure, it could involve multiple manufacturing methods. One of them is the sand casting process, or one of them is the casting process, as he is going to go ahead through this video.
Cast me up a nice base and go ahead and make one.
Yeah, so this base, it will be made by casting. There is another thing, and this is the thing that you are going to study, whatever, depending on your major is mechanical or industrial engineering, is to take a decision about which should this most suitable manufacturing method that should be used for making this product with this shape. So for example, making this base, the easiest way that he recommends, and this basically what we are doing, is that we can simply do casting to this base. This is one of the easiest methods of making this base with this shape. That this casting process, he gonna melt some aluminum or depending on the material that he's making this base from, then he's gonna follow the general procedure of the sand casting to make this base with this shape, right? And this is what he's gonna show us here.
That's why we metal cast, is to make something we need. So I'd like to invite you to stick around and watch the video. I've tried to stick with wire.
Yeah, so
This here.
this thing here, this is known as the pattern, as you already written here. This pattern, it is like a prototype with a slightly different things from the final product. So our final product is a base with a certain shape. So we have to make a prototype from another material that is typically similar to the final product that we would like to do by casting. This pattern, it is most likely to be made of wood. It could be made of plastic. It would be made of resin material, like as already shown here. It could be made of any simple material that we can shape, that we can make this pattern very similar to the final product. Our final product is of by casting. It is this base that it should be made of a certain metal. So he has made this base from a piece of plastic, as already shown here, which is very simple to make, and this is the pattern he's going to depend on it. So this is, you could say that making the pattern is one of the steps that you have to do in order to do sand casting process. So one of the essential step, and the first step actually, is to make this pattern. And these are the other components that just to end up that these wires, because in this video here, in this part, there are two wires. So these are the wires from which he's gonna make this pattern, this product. But anyway, this is the first procedure. He just made the pattern.
29.
Okay. Now what he is doing, this thing, these two things here, this is known as the flask. The flask, it is made of wood, as already shown here, for some simple castings. For bigger castings, we basically make this flask from cast iron, from metal, like cast iron. And this flask, as already shown here, it is two pieces, two parts. One part, and there is another part that can...
Well, here I'm putting powder down to keep the sand from sticking to the table, and putting powder on the pattern to keep the sand from sticking to the pattern.
Yeah, so he's putting this powder, baby powder, that is available everywhere, and just as he mentioned, just to not let the sand to stick to the table, or even the sand stick to the pattern, so the pattern can be easily removed from the sand, as already shown here. So this is, he's typically doing the procedure of the mold making. So what he is doing now, this is another process which is known as the mold making. So we started by making the pattern. This is step one. And the second step is to make the mold. Making the mold, it requires procedure by itself, as already he's doing here.
And now I'm going to put on some facing sand, and that needs to be sifted so you get a nice surface finish on the casting. And that only needs to be done on the pattern itself.
So as you can see, he's putting sand. This is a conventional sand with some other additive material. We could add some water, but with very small fractional amount of water that could be added in addition to other material that could be added to it in order to give it ability to be shaped, to stick together these particles of the sand to form a shape. So what he has done here, he have tried to put very sand grids of the sand very close to the pattern to give the final product a very smooth surface and good surface qualities. Then he's gonna keep on pressing the sand slightly around the pattern. Remember that the pattern is already dragged inside it, and he's adding more sand as shown here.
Chunky stuff afterwards.
and pressing the sand slightly over the button.
And I do apologize about the background noise on some of these clips, but it's unavoidable. It was just too hot. I had to run the fan today. So here we're compacting the rest of the sand and going to strike it off. And a little stubborn spot is going to give me trouble here. Took me 3 tries. Eventually got her done.
So after that, he's gonna repeat the same process. So this is the first half of the flask. He's gonna repeat, or the first half of the mold. He's gonna repeat the same process with the other part. But as you can see, the pattern.
Okay, now it's time to
here.
ram up the
Right?
top half of the mold. So I went ahead and tossed on powder. This thin tube is going to be my vent to allow the gases to escape. The thicker tube is where I'm going to be pouring the metal in.
So this thin tube, he's putting it just to form a vent. As he mentioned, this vent is known as the riser. In some cases, in some bigger, like bigger castings, we could use this riser as a feeder to keep on feeding the melt during the shrinkage process. But anyway, all of these details, definitely you're gonna study them through the manufacturing process class. But as I said, this is the vent which gets rid of the trapped gases inside the mold up on during the pouring process. And the other thicker tube, he just doing like a channel or something which is known as the sprue, the down sprue, just to allow for the pouring of the liquid to fill into the mold cavity. But remember, we still having the pattern already sticking to the sand, inside the sand, or trapped inside the sand at this instant.
So I'm just compacting all the sand.
So it's gonna keep on packing and for the other part, then he's just gonna get these tubes out to form the, as I mentioned, the 2 vents, like the 2 openings. He's gonna pour the liquid from this.
And a little bit of cleanup.
Yeah, he's gonna like pour the liquid from this opening, and the other opening, it will be like a vent that allows for the easy escape of the air that is trapped inside the mold cavity. And remember that the battery is still inside the mold. So this entire thing is known as the mold that is entirely made of sand.
Area around where the sprue comes in.
Yeah, now he's gonna open again the 2 halves of the flask or the mold.
This clip, I'm clean.
Yeah, so this thing, as you can see, he's trying to get the button. The button is already found or formed here. It is already on the top. It is trapped inside the sand, yes. And he's putting like a little bit screw that he made it before so he can easily
out
the button from the sand.
Where the screw comes in, that's where you pour the metal. And I'm preparing to go ahead and cut the gate.
Yeah, so this little small opening that he have done, it is related, it is just the base of this other opening, because you do have the 2 halves, one on the top, the other, and this should be at the end. Do you see this opening? This opening in which he's gonna pour the liquid. The liquid is gonna move down. Now he's doing a runner or a gateway to fill into the cavity, because this thing, it should be empty after a while, right? So he's just forming this.
To run over to the pattern. And this is where the metal is going to flow to fill up my little void in the sand there. So I'm just going to smooth it out, make sure there's no loose sand. And now I'm tapping on the pattern to go ahead and kind of release it a little bit. And I have a screw in there that I'm tapping madly so I can pull this thing out. And blowing off a little extra sand.
Yeah, so as you can see, it is not that easy to get the batten out. So we have, and this is one of the things that you are going to study in the manufacturing class, that how you can design this batten so it would be easily get out from the sand. And there are some precautions that we have to take when we get this batten out of the sand, because if some reason, if getting out the batten out of the sand have resulted in breaking the sand, we have to repeat the mold one more time. So we have to be curious when we get the batten from the sand. As you can see, we do have like a runner or a gateway that is going to fill. So assume that the melt comes out and it's gonna go through this channel, this very curved channel, and it's gonna fit into this mold. And once we leave it for a while, till solidification, we're gonna end up with the final product. So this is the basic idea of the sand casting, how it works. Now it's
And time to put the
half on it. So as you can see, now we get out the, we already taken out the batten from the sand. So now simply if we pour the liquid from this opening, it's gonna go through the runner to fit into the mold, which is already empty inside this mold.
Back onto the drag. I'm gonna prepare me a little pour cup. Give me a larger target to hit when I'm pouring the metal. And
here, this is like
ready to cast some metal.
He's doing a boring cup
like the furnace.
On the top here. So this boring cup is gonna be like, as he just mentioned, it would be difficult for him to target the very, very small opening of the sprue to fill into the mold cavity. So instead of, targeting this opening, which could be kind of difficult for him to do so, he has prepared this cup, and instead of targeting the opening directly, he's gonna keep on pouring the liquid, the melt, into the cup, which it will be smoothly go through this sprue or this opening to fill into the mold cavity here. So the next step, so now this is the second step. So the first step is just to prepare the mold. The first step is just to prepare the batten that is made of wood, plastic, or any easy simple made material. And the second step is to prepare the mold. As you can see, preparing the mold requires a procedure that is made of the sand. Then the third procedure or the third step, that he's gonna melt the metal. He's gonna bring the metal that he is interested in making this base. Remember that we are making a base. It could be made of aluminum or copper or whatever. So depending on the material that he's decided to make, he's gonna bring some solid material from this material parts, and he's gonna melt them using this little man-made or simply handmade furnace. So this is like the furnace. He's gonna use it for melting the liquid, and then he's gonna pour this liquid into. So this is melting the liquid, melting the metal. This is the third process. So the metal is already inside, that it is already melt. Something also that you should understand, that this is what we have discussed over the previous videos. We said that, think of it how this thing, this container, it is already made of metal, right? And we're already melting another metal inside it. So why this container, it is not melted? I mean, this furnace itself, it is not melted. It is already covered from interior. As you can see, the interior of this furnace, it is not metal, it is made of ceramic. And as we mentioned, ceramic, it is a good material, it is a good insulator for heat. So that's why it is like a special furnace. It is like any conventional container. Even the container itself, it is made of aluminum. Aluminum, it is very weak material, it will be melted very quick. But we already backing inside this container, this aluminum container, we are putting this cover of the ceramic, and we are going to melt inside the ceramic itself. The ceramic, it is good heat resistor and heat insulator. It means that the exterior, it could be heated somehow, but it will not be melted. And also, as you can see, these bricks are made of ceramic. These bricks are ceramic material. They are good also insulators for the heat and temperature. Okay, so what he's doing now, he's just keep on melting. As you can see, this is the melt. What he's removing is just removing something that we call as a slag, and this is the pure metal that he already melted. Now it is liquid. Okay, now he's gonna keep, curiously, he's gonna, gonna keep on pouring the aluminum, I think it is made of aluminum, yeah, into the cup, and is gonna keep on filling. As you can see, this extra thing that came out from the vent, this indicating that the mold cavity has been completely filled out with the liquid, and this extra thing, it will be then removed. Okay, so this is one of the useful things of the vent, that it gives us an indication that the mold has been completely filled inside the mold cavity, filled with the liquid inside the mold. So this is the mold. Then he's gonna keep it for a while till it will be completely solidified, till we gonna end up with the product. So this is after the solidification. Now he's getting out the product from the sand. He's gonna break everything that he prepared. He's gonna break the sand again, as you can see. So this is the casted product. This is the product after casting. This is the product after casting, but it is not the final product. It is not the exact shape of the base that we needed, that he showed in the start of the video. But anyway, he's gonna break the sand, and this is the casted product. It is now completely solid. As you can see, there are some extra portion that should be trimmed. We have to remove this extra portion, but anyway, it will be still there, and then we can trim this extra portion to end up with the base itself that is already made of aluminum, or the material that he was using. Now he's gonna use this vise just to fix the product, and he's gonna do some trimming, as I mentioned. So this is after casting processing. So we started by making button, then we made the sand, the mold made of sand, then we milled the metal, then we bored the metal. So this is step 4, boring the metal into the mold, leaving the mold for a while till the solidification. This is the first step. Then breaking the sand to end up with the casting product. This is the 6th step, and the 7th step is just to trim this vent and the sprue, or the riser and the sprue. And the 8th step is to do post-processing. Post-processing is to do machining. This is required machining to clean up this product to be as should be for the exact base as he showed in the start of this. So he's trimming. It is easy to trim these things by hand, but it is better if you use this tool, this grinder, to trim it. As you can see, this product, it is not clean. I mean that the surface, it is very rough and it should be cleaned. So he's doing lots of other grinding process to clean it up.
Well, in these series of clips, I'm just taking the angle grinder with a 60 grit flap disc. And
so this is a grinder. This
metal.
Grinder, it is known as the grinding process. Although he is using this small machine grinder by hand, but there is a grinding machine that already used as for doing grinding. Grinding, it is mainly used for making surfaces smooth, like the sand grinding paper, like the sandpaper, for example, that's used for grinding and cleaning surfaces and making surface smooth. This is typically the same. So this process, it is a machining. This is not a shaping or casting process. So what he's doing now, it is another category of manufacturing process. We said that we have shaping, forming, and machining. What he is doing now, it is machining. Not shaping, not
along the edges.
Nothing. It is machining process. Why? Because there are some parts, small particles that is going to be removed.
So I moved over to the angle.
Upon grinding, there are small particles that will be removed to clean the surface, to make the surface smooth. These particles will be the form of a chip. And we said that if we cut a chip or something that will be removed from the material, this will be counted as a machining.
For the bench grinder. Take a little bit off.
So it's gonna keep on grinding and making sure of the dimension till cleaning the product. So this is the base.
Some things I'm not. Soldering is one of them.
Yeah, so now he have finished. As you can see, there is, let me show you how he
my best swap. This is my third hand.
Yeah. So now he finished, should be finished of the base. Now we would like to do like 2 holes. He's bursting. This is known as drilling. He's using the driller, which is this hand driller machine, but simply we can do the same thing over the drilling press machine, which is a huge machine that already found in any workshop, and he's pressing. So this is another machining process. Now he's doing machining, he's doing this, he's bursting in it. This bursting process is known as drilling process. This is one of the machining processes. This is not a shaping process. So he's making these holes. Now he's gonna weld these wires.
But for the sake, well, I was originally going to use JB Weld on this project.
So this like a glue. This gluing process is like welding process. It is very similar, the same concept like the welding process, which is another shaping process, because this glue should be liquid, then it will be kept till certification. So it
is these copper
like
wires
casting. It is counted as a shaping process till he end up with his final product. So as you can see, to make such a product, it is not just one process. He used casting, he used different machining processes, he used grinding as one of the machining process, he used drilling to open the holes, he used welding, another shaping process to weld these sticks to the base. Make sense? So this is very comprehensive video actually to know about the casting process. So again, casting, it is simply to, once we mention casting, don't stick to the word, stick to the procedure. Understand the procedure. What does it mean, casting? Make sense? Alright, this is another video that I'm gonna go over it very quick, then I'm gonna keep it for you watching at home. If you are interested, this is like another industry that depend mainly over casting. So as you can see, this guy's already throwing this raw material, this solid material into the furnace for melting, and after that it will be completely melted. So this is a furnace, this is one of them, and this is the melt itself. This is the melt, this is the metal after it had been converted and melted into liquid. And this is so this is a pouring process. So this is the mold. This is a mold that is made of metal, and he's pouring the molten metal inside it. So this is known as die casting. This is another different than the sand casting. But as I mentioned, there are lots of casting processes. Sand casting is one of them. Okay. Yeah, this is the mold. As you can see, this is a mold, and these are the flasks of the mold. So that's fine to get off the flasks. So all of these are different molds, and they already melt the metal and keep on pouring. So as you can see, this machine, do you see how huge it is? So he's keep on pouring the liquid into all of these molds, and these are the molds will be broken after to get the final products by the casting. So I'm just gonna let you with this video. It includes, this is one of the factories that would depend mainly over the sand casting and casting processes in general. So it would be interesting if you can all go over this video at home. Make sense? Okay, so after watching these videos and understanding what does it mean casting, especially the sand casting, what are the advantage or disadvantage of the metal casting process in general? As a good thing of the metal casting, that we can use it for making complex shapes. Whatever it is, easy or complex shape, we can make it. If even the complexity and the lots of detail, if we have a product with so many details, we can easily make it using the metal casting process. Also, it can be used for making very large parts. We can produce products that over the weight of this product could be over 200 tons, which is a huge piece of product that also can be made using the casting process. Generally speaking, you could say that if you do have huge products, the only possible way to make them is using sand casting. This is the easiest way and the only approach that we can make them, because this product is huge, it is big, so it could be difficult for us to find a machine over which we could fix this huge product over the machine. So the easiest way, as I mentioned, the only option that we're gonna have in that case is using the sand casting process. It is applicable to any metal, whatever it is. Any metal in a way it can be melted, it can be converted into liquid, so simply you're gonna pour it into the mold and you're gonna end up with a product. Also, it is mass production process. So what does it mean, mass production? Mass production, it means that you can use this process to make multiple types of one single product. So this is known as mass production operation. Mass production, as I mentioned, like you do have one product with a certain feature, with a certain shape, and you would like to have millions of copies of this product, like millions products of the same type, of the same shape, and so on. So this requires a manufacturing process that it could be used as mass production. As I showed you over the second video, I showed you like these guys already have prepared lots of molds, and they're gonna keep on pouring into these molds at once, one by one, right? So it means that this is a process. All of these are the same molds of the same products, of the same product. This means that there is a mass production process. Mass production, as I mentioned, that you're gonna have multiple copies of the same product with the same feature and shape, so we can use the sand casting process for such a thing. Also, size variety from big and small. We can cast so many products, whatever they are small in size, like the base that I showed over the first video. Even we can make casting for huge parts, as I mentioned, over 200 tons. Also, some of the advantage, but in the meanwhile, it has advantage. So the disadvantage or limitation, that the thing that you should understand, what are the good thing and the bad thing of using this casting process. One of the bad things actually that they provide poor mechanical properties. The products that are made by casting, they are not mechanically preferred. Their mechanical properties are poor or weak in comparison to any other manufacturing method. In many of the cases, they badly affect the surface properties as well. There is poor surface properties. Products usually contain defects. As we mentioned, we have to do lots of things after the casting, because once we get the product from the sand, especially the sand casting, it comes very rough. It has dirt, it has defects, it has cavities over the surface. So all of these defects, it is a serious problem and one of the limitations of the metal casting process. Also, low dimensional accuracy. The accuracy of the dimension, it is not high in comparison to any other manufacturing method. It requires post-processing. As I mentioned, once we finish the casting process, we have to do post-processing to clean the surface, to trim the vents, to clean the surface, to make it smooth. So these require more manufacturing processes after the casting, and these extra manufacturing and post-processing, it is a cost. It requires cash, it requires cost. Also, safety hazard and environmental problem, because since we are dealing with a metal at very high temperature, the temperature of the metal, it could be reached up to 3000 degrees Celsius. So it is very dangerous to the operator who is dealing with this liquid. For some reason, if something went wrong, definitely a catastrophe is going to take place. And in addition, the melt of the metal requires furnace, and this furnace definitely they do have some bad impacts over the environment. So these are the limitation of the metal casting in comparison of the good things of the metal casting. And as I said, all the steel making depend on the metal casting. It is a huge industry. This is a typical explanation or diagram that shows the mold that we were discussing over the video. We said that the mold, there is mainly made of sand. These are the two pieces of the mold. The top part of the mold, we said that we do have a flask. The flask, it should be two pieces that separate from a surface. So the surface that separates them is known as the parting line or the parting surface. So this is what parts the top part of the mold from the lower part of the mold. And the top part is known as scoop, but the lower part of the mold is known as the jag. And this is the mold cavity. This is the empty thing that it will be filled with the mold. In some cases, we could use something that we call as core. So the core, it is something that is used for making any features which is internal into the final product. And anyway, in the manufacturing course, we're gonna go over more detail about the core thing in the when we discuss the casting process in the manufacturing course. But anyway, this is the mold cavity that it should be filled with the liquid. In some cases over the video that I showed you, we didn't use cores, but we could use this core to prevent filling the liquid into some spots or some places into the mold cavity. So we're gonna form internal hole, for example, into the mold itself. This is the riser or the vent that allow for the escape of the gas. In addition, we could use this riser as a feeder that is gonna keep on feeding the liquid up on shrinkage. So there are lots of details here that I won't gonna go over them because this is gonna take time and this is not the focus of this course, as I mentioned. This is the other vent or the channel, and this is the runner that the curved runner, if you remember in the video, that the guy he has formed in order to allow for the transition of the liquid to fill into the mold cavity. In addition to this is the other vent with the bigger tube that was used to fill or for the pouring of the liquid into the mold. So the guy is pouring from here. This is the pouring cup, and this is the down screw, and the guy is pouring from this direction. It's gonna fill into this down screw to fill into the runner, fill into the riser, and fill into the mold cavity. Then we're gonna leave it for a while, break the sand. You're gonna end up with the product at the end. So the product, it should be this little thing. This is the product part. All these things and the product, it should be with a hole, and these extra things are just channel known as the gating system that allow for the easy transfer of the liquid to fill into the mold cavity for the mold. Make sense? This is the procedure that I showed you over the video. We said that we start by preparing the pattern, having the same shape of the final product, and we said that this pattern should be made of wood or plastic or any easy made material, manufactured material. Also, then we are making the sand. We prepare the sand from which we are going to make the mold. The third step is just to make the mold, that pouring the flask, backing the sand about the pattern and repeating for the other part, and then you're gonna remove it, form the vents and the gates and the runners, remove the pattern from the sand. This is known as the mold making. Or mold preparation. Then you're gonna melt the molten metal and pour it into the mold cavity, leave it, allow for solidification, then break the sand to get the product, remove the casted product from the sand and clean it. And then you're gonna do post-processing. As I mentioned, post-processing, one of the things is doing grinding, using the grinding process just to clean it and make the surface smooth that can be, and bring it into the shape that we can use. So this is the general procedure of the sand casting as one of the shaping processes, as I mentioned. Make sense? All right, so now let us move to another shaping process, which is welding. We said that shaping, it should involve melting the raw material in order to end up with a product, right? So welding is one of the shaping processes that basically used for joining or forming a shape or a product by joining materials together. So welding, it is the process of joining materials by using high heat and or pressure. In some cases we could only use heat. In some other cases we could use heat and pressure in order to melt the two products together. Like you do have two pieces, two metals, two parts that separate, and you would like to join them together by welding. So joining, we can simply gluing them. So this is like the glue. So glue, it is kind of welding. But here we are talking focus more over welding using metals. Like you do have two metals and you would like to weld them together. It is not just using the glue, but instead you are going to use one of the welding process. So in this case, we are going to apply a heat at the weld bed or the weld zone. Like within this weld zone, within this little small area, we are going to apply a very huge amount of heat that it should be big enough and very concentrated within this weld zone. This heat is going to be used to melt Melt, we said that is to convert the metal into liquid state. So we are going to melt the metal at the weld zone, very small, so you can even observe that it has been already melted. Then after, with some pressure, we are going to join and making these two parts like a single part. Because if you melted the metal from this part and melted the metal from the other part with a slight pressure between them against each other, you are going to mix the two materials together, and upon solidification, once they turn back again to the solid state, they're gonna be completely like one single part. So this is the basic idea of welding, and since it involves melting, this indicates that it should be grouped as a shaping process. Make sense? So this is simply, in some other cases, we could use only heat. There is no need to apply pressure. In some cases, we can only use even pressure, and upon pressure and some certain motion, we can apply some heat is going to be generated, and this could involve some diffusion of the atoms of one part to the other part to form a weld. It means that also these are another type of the welding process. So welding, it is a general procedure. It is a general approach of making product that involve or include so many other different types of welding processes, like gas welding, we do have arc welding, resistance welding, solid state welding, and so many other, like frictional welding. So there are lots of other welding processes that can be classified as welding. So the objective here is to understand what does it mean welding. So again, it is joining of materials by using heat only, or using heat and pressure, or only just pressure, to melt the parts at the weld zone. The objective is just to melt. So the melt is one of the conditions of the weld parts at the weld zone, at this small area of welding at the contact surface between them, where after cooling the weld is going to be formed. Make sense? I'm just gonna let you with this video that give you an example of the welding process, something that I'm pretty sure that some of you have seen this welding process before, and then we are going to go over the different types of welding processes. So over this video, this guy is showing up like lots of details, which is technical. He is an instructor of welding in a technical college. So, and it is very technical thing. So we won't gonna go through the details of the technical issues that he is describing through this video, but I'm just gonna jump here just to show you this process. This process is one of the welding processes known as arc welding, and arc welding, it is a general title that includes so many other arc welding processes. So arc welding is one of the welding process that using electricity in order to generate the heat, and it depends on the ease of the transparent of the electrons through the electricity that is going to hit the surface of the metal in order to generate heat. So it has a concept, it has a theory behind the generation of the heat in order to melt the metal at the welding zone. So I'm just gonna let you with the video, and then I'm gonna give you some more details.
Concentrate on doing this, and hopefully we'll see some slag peel out of it too.
So this thing that he is putting here, this is the filler material, or which works in the meanwhile as electrode. So this thing here, this is thick, this is known as the electrode, and in the meanwhile it works as a filler material, and we are going also to discuss this. And this thing, the other side he's handling, this is the torch, which is already connected to an electrical source. So this is the electrical power or the electrical source, which is he set up some electricity that is going to generate through this wire. This wire takes a charge, and the piece of metal takes the other charge. So that's why it is over like a metal table to allow for the electrical conductivity between the positive and negative charge between this electrode, and the metal is gonna work at the other opposite electrode. And as you can see, once he touches, so initially he works in this way.
Come on, darling, light up here. Don't be that way.
Yeah, so as you can see, it is not that easy. So that's why the welding process, it depends mainly over the experience of this guy who's doing welding, right? So that's why he's talking about in this video about the very technical things. And So based on his experience, how you can end up with a good bead of welding. But anyway, forget about these details. But the issue is that first, you have to touch, this is something that depends on the theory of the arc welding that you should understand, that we first have to touch the surface by the electrode of the workpiece. Why? To close the circuit, to close the cycle of the electricity. As long as the electrode of this torch is away from the workpiece surface, there is no electricity is going through. There is no electrons. Electrons are exactly found at the tip of the electrode and over the surface of the workpiece. But once they touch each other, we are closing the circuit, we allow for electricity to go. Then we have to get away from the surface. We have to remove, slightly reduce a gap, a very small gap between the electrode surface and the metal surface. This gap, it should be small enough, because if it is bigger, we are going to disconnect the electricity one more time. But if this gap between the electrode tip and the surface of the metal, if it is too small, this allows for the electrons, because electricity anyway, it depends on the movement of these electrons. These electrons, they're gonna go through this gap, this small gap, which would include an ionized air an ionized gas or air that allow for the transfer of the electrons from the electron to the surface of the workpiece. And once these electrons, they're gonna hit to the workpiece surface, this dissipates energy. This energy will be converted into heat that is big enough to melt both the metal surface and the electrode, which is gonna work as a filler in that case. So this is the theory, this is the concept behind the arc welding process, how it works. So we are depending on generating electricity and generating heat by electricity. Why? How? Simply, we have to touch first the surface of the metal to close the cycle. Then we have to separate the electrode from the surface of the metal, producing a small gap. This gap, it should be small enough. So that's why it depends on the experience of this guy. And this gap, it includes ionized air that allow for the transfer of the electrons at very high speed. These electrons, once they hit to the surface of the metal, they're gonna heat it. They're gonna produce a very huge amount of heat that is going to melt both the metal and the electrode. And in that case, we are going to perform the welding operation. So that's why initially it had been a stick from him. So as you can see, there is a spark. This spark shows because of the heading of the electrode. The electrons, they are heading to the surface. So that's why these sparks are generating. Yeah, so as you can see, this is the bead of welding that he has formed. All of this material, it had been formed by mixing both the metal itself that he's welding in addition to the stick. This is the electrode, which is already melted as he keep on going, and now it had been a stick. So this is an issue, and he's gonna figure out how he can fix this thing. But anyway, this is the basic idea of the arc welding process, how it works. Make sense? Alright, so this is the arc welding that I just showed over the video. The arc welding is one of the welding process, but remember, in addition to the arc welding, there is gas welding. There are lots of other welding processes. One of them that is already seen in the video is the arc welding. Arc welding, it uses heat only. There is no pressure. As you can see, the guy, he didn't press the two pieces that he's welding together. No, he just applied a heat. And this heat has been generated by an electric arc. So this is the electric arc, which should be next to the electrode and the workpiece surface next to the sparks that are already seen. Between the work part or the work metal and the electrode of two opposite charges to melt the parts at the welding zone. As you can see, as already shown in the video, as I explained, this is the electrode holder or the torch the electrode holder that we are fixing or holding here, the electrode that is already taken one charge that is connected to the electrical source, and the other charge is already delivered to the metal. And as I mentioned, we have to touch the surface first to close the cycle or the circuit, the electrical circuit. This will allow for the electrode, just excites the electrode to move from the electrode to the workpiece surface. Then we have to remove the electrode from being touching to the workpiece surface, producing a gap. This small gap should be small enough to allow for the continuous transfer of the electrode. As was seen in the video, the gap was very small, so it depends on the experience of the welder. This guy, he has been practiced over here to do such a thing, and at the end we are going to form the weld, and these sparks produce because of the hitting of the electrons to the workpiece surface. In addition to the arc welding, there is gas welding. As I mentioned, there are lots of welding processes. One of them is arc welding, one of them is gas welding. So this is another welding process that uses heat only generated, and this heat is generated by burning a gas fuel mixture. Like oxyacetylene is one of these methods, like we are producing a mixture of oxygen and acetylene in order to produce a burn and a fire that is going to generate a certain amount of heat that is big enough to melt the two pieces or the two parts that should be welded. In some cases, we can add a filler, another external rod that is going to fill into the weld bead or the weld zone in order to produce a weld between two pieces or two metals. Okay, but here the key condition or the difference between gas welding and arc welding is, in arc welding we are generating heat through electricity, but here we are producing heat by burning gas fuel mixture to melt the metal parts. Examples of these are the oxyhydrogen or oxyacetylene. As I mentioned, this is some of the gas welding processes. So what I'm gonna do, I'm just gonna let you with a video that explains in detail how this gas welding process is done.
Today we're going to do some oxyacetylene welding. I'm going to show you how to set up your regulator tanks, how to safely use your torch, and how to do some basic fusion welding with some flat bar. This is just regular steel. So first off, setting up your tanks, we've got two here. We have an oxygen tank and we have an acetylene tank. I have a little rhyme that I follow for all of these steps. It's always going to be A before O, acetylene before oxygen, or up you go. Don't ask me why, but it's going to help you remember every single step. So before I get started setting up my tanks, I need to make sure that my torch and everything has been set up correctly. We need to make sure that the tip, there's a tiny little hole here. We need to make sure that the tip is clean. It's hard to see. You need to make sure the tip is clean. If you do need to clean it, and you can tell once you actually start welding, you can use a tip cleaner. Tip cleaners look something like this. You need to pick the right size for the one that fits in that hole. First, we're going to do the acetylene first. We're going to open up the main valve here half a turn. So if this is my start, I want it to get to here. And I've drawn a little line here to help remember. Half a turn. Now, the last person who used this did not purge the valves, but usually when you get to it, let me just purge that valve for a second. Release the pressure on my regulator. There we go. This is basically how much fuel is left in the cylinder, and this is how much pressure will be coming through. So in order for me to increase pressure that is going to be coming out of my torch, I'm going to have to adjust the regulator. I'm going to open up the knob on my torch handle for the acetylene or the fuel. Just open it up. Don't worry about how big it is yet. And I'm going to adjust the regulator here. I'm going in the plus. You can see plus or minus. I'm going plus, and I'm going to increase it to about 6 psi. There we go. We're at 3, 4, 5, 6. If you look very closely there, and you can hear the acetylene actually coming out. Go ahead and turn off your knob. This one is set and ready to go. Next, we have our oxygen tank. We need to adjust this till we have between, I'm gonna say 5 and 10 PSI coming out of this. We're gonna open this valve all the way until it stops. We're gonna take our torch handle, open up the oxygen, adjust the regulator until we have between 8 and 10 PSI. It's hard to see the numbers, but we just need that little valve needle to show it just a little bit. Right there, that's good. Turn off your torch valve. So if you look closely, you can see that the needle on the left is just open a little bit. And down on the acetylene, it's around 6. Let's zoom in there a little bit. You can see that the PSI is just about 6. If you look on the left dial, you can see that there's a red zone. Do not push acetylene past 15 PSI. Next, you need to have some sort of eye protection. We're gonna be using a number 9 screen here. This allows it to protect your eyes and your face from the heat, mostly your eyes so that your eyes don't hurt while welding. Welding with just bare eyes is gonna hurt for a while. You need to have a set of gloves ready. We're using leather gloves here to protect from burns. And I've got pliers here to pick up hot material after we've been welding. If you pick up hot material with bare hands, you're gonna get all blistery. I'm gonna set up my 2 pieces of flat bar here with a slight gap in between. And I'm using fire brick to prevent my table from getting hot, and fire bricks will not explode when heated or anything. So now that I have my metal set up, I have my torch all ready to go. All I have to do is open my acetylene valve just a little bit, or fuel valve. This one's using acetylene. Open up just enough that you can feel it on your hands, or you can put it up on your ear and actually listen. I'm wearing these wicked glasses. Just enough to feel it. Take your striker, hold it on a slight angle beside here, and you get a nice sooty flame. All that black stuff is carbon. We want to get rid of that or it makes a big mess. I'm going to open up my acetylene valve until that black smoke goes away and I have a nice feathered flame. Delicious. If you're doing thinner material, you don't need as hot of a flame. In this case, we're doing 1/8 inch flat bar, so I'm going to open that up so I get a nice roar. I don't have a special number for this. Beautiful. Next, we're going to open up our oxygen and add some oxygen to this mix. Watch carefully what happens to the flame. Now, if you look at it, it looks like we have 2 different cones here. We've got a very bright one, and we have a longer one here. Don't try to touch it, but you can get pretty close without feeling any heat. I'm not going to purposely do that though. All right, I'm gonna adjust some more oxygen until that one cone gets nice and tiny. So here's just, I set the exposure on the camera down a little bit so you can see the 2 different cones. When you first have just acetylene, you've got that, add your oxygen, and you're gonna see 2 different color flames essentially coming out. We've got a short bright one and a long one there. I'm gonna add more oxygen until I have a very nice little cone that's maybe less than 1 centimeter long. All right, let's do some welding. So I have my flat bar set up with a very slight gap in between. I want to have a little bit of a gap to allow the metal to penetrate when it gets welded together. I'm going to start by tacking both ends, and then I'm going to do a fusion weld. To tack first, I'm going to heat it up. I'm going to hold my torch on about a 45-degree angle and kind of zigzag between the 2 pieces while concentrating on one area. If this is taking too long, you could increase the pressure and get more heat. What we're looking for is both pieces of metal to basically turn molten. You'll see it start to get shiny on both sides, and then those 2 shiny parts will join together into one puddle. Back and forth, let them join, there we go. There we have now a little puddle. I'm gonna do the same thing to the other side. I've dropped the exposure on the camera so you can get a better look at what's going on here. So I'm holding my torch on about a 45-degree angle, zigzagging back and forth between the 2 pieces. I'll hold the torch on the other side so you can see better. and I want to get a nice little puddle going. Back and forth between the two. And I'm just hovering above the metal. I don't want the torch to actually touch the metal. Here comes my puddle. Should join soon. The two sides are getting molten. And I want those two little puddles there to become one. Wait for that moment. You can do little circles or zigzags. There it is. You see that? Now we have a nice little join. Now that I got my two sides tacked, I'm going to practice laying a fusion weld, which is basically taking that puddle and pushing it down the length of my joint here. Whether you're left-handed or right-handed, it doesn't matter. You got to find a way that works for you. I'm going to go in this direction and push my puddle that way. So I'm going to heat it up, get that puddle molten again. I'm holding my torch on about a 45-degree angle. Get that thing heated up, and then I'm going to push the puddle. If I stay in one place for too long, once my puddle's going, I run the risk of actually burning through and burninating my metal. There we go. Keep your heat even on both parts of your metal. There we go. It's getting shiny. I'm waiting for that puddle.
So welding till he finished the product.
Here it is.
Till he will finish the product, it will be welded as like a single piece in that case. So this is the basic idea of the gas welding. Another type of the welding process is resistance welding. It is kind of similar to the other methods, but also it generates heat and pressure. So the difference between arc welding and gas welding, or the common between them, that we are using only heat. There is no pressure. We are not pressing the two pieces together to be welded, but instead we're just using heat to achieve the welding by melting the two pieces together. But the difference between them is how we are going to generate the heat. In gas welding, we are generating the heat by burning gas fuel mixture, but here we are generating the heat by the electricity, by allowing for the electricity electrons to move between the electrode and the workpiece surface. But resistance welding, we are depending on both heat and pressure to achieve a weld, or to achieve a weld nugget or weld point. So it is a welding process that uses both heat and pressure to form a weld nugget or a weld point between two pieces. So these are the two parts that should be welded together. And these are two electrodes. Everyone getting different charges. So this is like a positive charge. This is like a negative charge. They already connected to an electrical power. And here we are not depending on the ease of allowing the electricity to move, but it depends on the resistance of the electrode material in addition to the resistance of the two parts that shall be welded together to allow for the electricity to go through the electrode and the positive and negative electrode. As this resistance to the electricity increases, the amount of heat generated will be higher, will be bigger. So it is a different concept, it is a different theory or approach of welding that depend on the resistance more than on the dependence on the ease of allowing electricity. In arc welding, as we allow for more electricity to go, we are going to generate more heat. But here, as we resist the electricity to go or to flow, this will produce more heat. So this depends on the resistance. So that's why we get the name of this welding process as resistance welding. The heat generated due to a high electric resistance. But there, it depends on the high electric arc. Like we allow for more electricity to go, but here we have to resist more the electricity to go, which is a maximum, will be maximum at the contact surface between the two parts. Therefore, so the resistance will be the highest or maximum at the contact surface between the two parts. So this requires that you should have two pieces, one on the top, the other, and the weld nugget will be produced at the contact surface between them. This is the weld bit or the weld nugget point that depend on applying pressure that we have to press, so there is a force here. In the meanwhile, we are generating heat through the resistance, so we are depending on both heat and pressure to achieve the weld. This is the basic idea of the resistance welding. Another type is solid state welding. Solid state, from the name, indicate that there is no welding that is going to take place, but there is another process that is going to take place which is very similar to the welding, known as diffusion, that allow for the diffusion of the atoms of one metal to inside the other one in order to form the weld. And this requires achieving a very high friction, that it should be big enough to achieve a very high heat that allow for the diffusion of one atom of one part through the atoms of the other part, or mixing the atoms together to end up with a weld between the two pieces or parts that we are interested in welding them. So solid state welding, it is welding process that is used for joining two parts with only pressure. We are depending only on pressure. As we mentioned once before, we could use either heat only or pressure only, or both of them, like the case of resistance welding. Here we are using only pressure, where no heat is required. We are not heating, we are not generating any external heat, but the heat will be automatically generated through the friction to melt the two parts together. Like the frictional welding or friction welding and ultrasonic. This is a typical example of ultrasonic welding that we are applying. This must indicate that there is a very high pressure over the two parts. These are the two parts that shall be welded together. And this is an ultrasonic transducer that is used for generating a very high vibration that makes one piece moves very fast with respect to the other one. Even rubbing your hands together, moving them together, this will produce friction. This friction will make your hands heat up, and this heating produces because of the friction. So this is very similar thing that we are doing for these two pieces, that we moving one with respect to the other very fast using this ultrasonic transducer that is going to produce a friction, very high friction. In addition, with the aid of the pressure, this friction will become more and more bigger, that will produce a certain amount of heat that allows for the diffusion of the atoms of one part through the atoms of the other part, and mixing these atoms together at the contact surface, and then they're gonna be like kind of welded and stick together like one single part. So this is the basic idea of the solid state welding. One of them is the ultrasonic welding as one of the types of the solid state welding. So in addition to this welding, there are lots of other methods of welding, but generally the common between them that we have to melt the material at the contact surface between them, so we can melt them together and form a shape from these two materials together. So that's why they are classified as shaping process. Make sense? So that's it for this video. Over this video, I have discussed in general, what does it mean manufacturing? We discussed the three categories or the general classification of manufacturing processes into shaping, machining, forming. Also, we discussed the shaping processes. Over the next video, we're gonna continue and we're gonna discuss the metal forming. Then we're gonna discuss the operation that would be used for machining. So we are going over the next video, discuss the metal forming processes in addition to the machining operation or machining process. Make sense? So that's it for today, and thank you for the watching, and see you in the next video.